So we're back in the lab, and the Trimyristin that we isolated has been sitting in the desiccator for about 5 days now. So I'm going to take that out of there and we can get a mass and calculate a percent yield. There I have my Trimyristin. And what I'm going to want to do before I transfer that is prepare a vial. With a label. So I'm just going to write Trimyristin on here. You'll actually write your lot number. And I'm going to weigh this vial. It's called tearing the vial, weighing it ahead of time so that I can get the mass of product by difference. And those labels don't stick on very well, so I'm going to tape that on there so it stays. I'll do all that before I transfer it so that I get an accurate mass of the entire vial. And while we're at it, I took the big flask that we had forgotten to weigh before out, so I'll weigh this and we can get a crude yield. And we're going to tear that so it's 0. And then we'll put the flask in there. And so that flask has a mass of 93.373 grams, which is what you'll want to subtract from the mass that we had before. And now my vial, my empty vial, has a mass of 5.996 grams. So I can put that flask back. You have to be careful when you're doing a reverse tear like that to make sure you're using the same flask. The best way to transfer that is to use a piece of weighing paper as a little miniature funnel, because the weighing paper has a shiny surface, which means the Trimyristin won't adhere to it. So I can make myself a little funnel. It'll fit nicely in the top of that vial. And that will enable me to transfer that without spilling it. So I need a spatula. That's probably a good one. And then I want to pull out that piece of weighing paper, so I'm going to pull a pair of tweezers here. So nice powdery white solid. And there's the weighing paper. I'm just going to grab a piece of weighing paper by the edge and scrape the remaining Trimyristin off of there. Make sure I don't lose much. It's a little bit sticking to the tweezers. I make my little funnel, and I can dump the Trimyristin in there. Let's see if I can get the last residue. Get as much of it out of there as I can. I got about a third of a vial, a little more than a third of a vial full, not too bad. And we can go weigh that so we can get our purified percent yield and our percent recovery. So from the crystallization process. So you'll have 3% in your notebook. You'll have the percent recovery, the crude trimyristin that was in that flask, divided by the original 4.313, I think it was. And you'll have then the percent recovery of this pure material versus the crude material, and then you'll have the overall purified percent. What percent is this of the original nutmeg powder? And this has a mass now of 6.253 grams. So you'll subtract the original mass of the vial from 6.253 to get your mass of pure trimyristin. So now we want to characterize this trimyristin, and we're going to use two methods of characterization for that. We're going to take an infrared spectrum, and we're going to take a melting point. So the first thing I'm going to do is demonstrate how to take an infrared spectrum. To get an infrared spectrum, we need to check out a kit from the stock room. That we'll use to make a potassium bromide pellet. And the kits are usually right here, so Ashley must have put it away. There's a little chart here. So I'm going to grab KBR kit number 6, and since I'm the only one here, I'm not actually going to sign it out. So I want to take the KBR kit with me, the trimyristin itself, and one of the smallest micro spatulas. Little tiny one with little V-shaped edge and then a tiny point. I'm going to take those three things with me to the station in the back of the room where the remaining equipment is for making a potassium bromide pellet. So, in this KBR kit, there is a nice agate mortar and pestle. Costs about $125 each. This one is one of the few that's actually not broken. And then there is a pellet making die that consists of 3 parts. There's a short kind of knob on a disc. There's a longer one, and then there's a collar. What we're going to do is we're going to make a mixture of our product in potassium bromide. And potassium bromide has the nice feature that when you press on it, it will fuse into a glass, so it will become transparent. And we have potassium bromide that's been dried in the oven, so it's a nice fine powder. All right, we don't want any water because then it won't fuse nicely. And we have special scoops here that are designed to hold exactly 100 milligrams of KBR. And now I'm going to go and turn off all the alarms because apparently the hood fans just went out on the roof, which is a fairly common occurrence. Fortunately, I'm not dealing with anything particularly toxic, so I can go ahead and continue to make my KBR pellet. So the first step of making a KBR pellet is to take a little bit of your material and put it in the agate mortar and pestle. And you only want about 3 salt crystals worth, or maybe like 1 grain of rice. Not very much. If you put too much in, your pellet won't fuse properly. So that's a good amount, right? Just a little bit, not very much at all. And we're going to smear that around in the agate mortar and pestle so it's nice and finely ground. And you'll know you're done when you can tip it upside down and it doesn't fall out. Now I want to add 1 scoop of the potassium bromide. This has already been ground, so when I grind that up in the mortar and pestle, I'm not really grinding the KBR, I'm basically just mixing it with the compound. So I'm going to use the KBR kind of as sandpaper to pull that material back off the mortar and pestle and get it thoroughly mixed so I have a uniform solid mixture. And it should be freely flowing, so when I shake it back and forth, right, it doesn't stick anymore. Unfortunately, today's a pretty humid day, so I may get some water in there, which we'll see in the final spectrum. All right, so that's freely flowing. It shakes back and forth nicely. I've probably been grinding that long enough. The collar goes on the one with the smaller knob, so that there's a well that I can fill with this. And then what will happen is I'll put that powder in there, we'll squeeze them together, and then we'll squeeze them very tight so that it fuses into a glass. And I want to use probably between 1/3 and 1/2 of this mixture. The important thing is to completely cover the knob, and to do it with a relatively uniform layer. Alright, so you can see that it's kind of a layer there. Looks like I'm going to have to go and turn off the damn hoods again, because that buzzing noise is annoying. Inspires confidence, doesn't it? Ohio Wesleyan is definitely ready for coming back to real classes. Alright, so we're going to put somewhere between 1/3 and 1/2 of that material in. So that we get a nice layer. I'm going to kind of tap that to distribute it uniformly. And then we're going to put this other piece back on. And we're going to grab one of these wrenches. Right. These are specially designed to press that pellet real tight. So we want to transfer that in without knocking it, or otherwise having it fall apart like it just did on me. Third time's a charm. There are all kinds of weird noises going on up here. I don't know what they're doing on the roof. We're going to transfer that in there this time, not allowing it to come apart, and press tight. It needs to be a little tighter than that. There should be resistance, but not so much that you can't take it apart. After we let that fuse for a little bit, it's sometimes very difficult to get it apart, so you can just kind of bang it on the counter, and that will enable you to pull the heater apart. And if all went well, and it didn't, so my pellet fell out, I'm going to have to start over here. Definitely having some humidity issues today in the lab. Fortunately, I still have half my mixture left, so I can try another pellet. Scoop that in. I've got plenty more material if this one doesn't work. Tap that down. It needs to be completely covering it so there's no holes. If there are holes around the edge, that's one of the things that makes it come apart. These haven't been used for a while. Oops, I just dropped it again because I'm a klutz. Having a hard time today. The hoods are about to go off again, I can tell. Well, let's hope this is enough.